have this particular question, we want to look at paper 1 2022 ECZ solved fully. We'll look at questions from 1 up to number 5. So without wasting time, let's see how we answer this question. So how we should present it is this. When they say evaluate, they are asking you to find the exact value of this. Meaning you don't have to simplify, but you need to find a certain value. And the value can be a number or a fraction. And a number decimal can be a fraction or a decimal number. So then how do you go about this one? So if you look at this one, we've got two methods on how we can go about this question. So I'll show you two methods. So look at it, method number 1. Method number 1 is where you write, if you see this particular question, this is a 3 over 2. 3 over 2 is a fraction inside the brackets. It's raised to the power negative 2. So then how are you supposed to do this one? So with the laws of indices, we see that this negative is in the power. So this negative is just the same as saying 1 over. Okay, take note. This negative in the power will be, this can be written as follows. We have 3 over 2 to the power negative 2. This can be written as this negative you see in the power will actually be 1 out of everything now. Of course, to say 3 over 2 in brackets to the power, this 2 here. I'll repeat once more. This negative you're seeing in the power is actually 1 over. Okay? 1 over what? These things here, 3 over 2 to the power 2 there. That's of course method number 1. Which, if simplified, this will give you maintain 1 over, you maintain, this will be 1 over 3 over 2 to the power 2. It simply means 2 of these. 2 over 3 over 2. So multiply 2 of these. So we are saying this will be 3 over 2 times 3 over 2. If you simplify further, you have the 1 over, remember, you go with it. So this is 1 over. The 3 times 3 is 9. 2 times 2 is a 4. Very good. Once you reach this point, you don't end here actually. You need to simplify further. How? So we now want to say this fraction can be expressed as this one here can be written as 1 here. Then this over, you can use the division like this. Then this 9 over 4, you just rewrite it here as 9 over 4. In other words, you are separating the same fractions, except the only difference is that we are just using a different way of representing the division operation. Instead of using over, we are using the division operation here. So 1 divided by 9 over 4, that's what we have. Once that is done, there's a rule that we use. If you are dividing any two fractions, as we're able to see, 1 can be expressed as 1 over 1. And 9 as 9 over 4 as it is there. So if you are dividing into fractions, if you are dividing into fractions, what happens is you have got the left-hand side fraction. That one has to be written as it is, and this is 1 over 1. Then as for the right-hand side fraction, it has to switch or swap. The numerator will be the denominator, and the denominator will be the numerator. The moment you do that, you need to change the operation from division to multiplication. And so here we're going to have times 4 out of 9. Then simplify further so that you have your answer. Now we're going to have 1 times 4. That is your 4. 1 times 9. And of course, this is your answer. 4 out of 9. Great. Let's look at method number 2 now with the same question. Another way, perhaps better, we could actually use is this method here. You have given to evaluate this particular fraction. This is 3 out of 2 raised to the power negative 2. The other method, the simplest one, is where you say this can be equal to, you see, we are dealing with a fraction inside the brackets here, and the power, the type of the power that we have is a negative. So what you do here is this. This negative power disappears. This negative power disappears. but this number remains as it is, as 2. This power remains as 2, but this negative disappears. The moment this negative disappears, the fraction that you have inside here swaps. I'll repeat. Another method, perhaps the simplest one, is whereby this negative power disappears. The moment this negative power disappears, we are going to swap the fraction inside, meaning we'll have 2 over 3. So then what I'm saying is this, we're going to have something like this, and the power no longer is a negative, but instead we get 2, then the fraction swaps. A numerator will be the denominator, and the denominator the numerator. So there we have 2 out of 3. The moment you do this, you have your answer, because 2 over 3 as a fraction raised to the power 2 is, this simply means 2 over 3 times 2 over 3. And this will give you 2 by 2, that is 4. 3 by 3, that is 9. And this is your answer. If you have got like terms, we are asked to factorize completely this particular expression. So first of all, you check if we have got like terms. In our case, we see no like terms whatsoever here. So then what we do, we go straight and try to factorize by grouping. How do we group? We pair them in 2's. Since we have got 4 terms, 2ax plus 4ay minus 3bx minus 6by, we pair them in 2's. Like this. Take note. This is what you do. Okay, this is actually what you do. Then as you come to this one, how we are going to take out is now like this. Observe carefully. The moment you put the brackets, remember, it means there's an alteration of some kind. So listen carefully here. So here we are not going to put the negative 3bx minus 6by inside the brackets. So what we'll do, we'll figure out where to actually put our brackets. Remember, outside that bracket there must be what is called, what is common. And from the look of things, what is common that we did earlier say, it was a negative 3b. Are we there? So where is negative 3b? It's from here up to here. Meaning our side, our bracket has to start it from here. Are we seeing? The moment you put the bracket here, remember, there must be something that should be different. So the moment you put the bracket here, remember, we've taken out what is common between negative 3bx and observe negative 6by. So then, here is what we must do. After taking out what is common, observe, after taking out what is common between this and this, what we do, we've taken it out. Then we want to figure out what remains. So then how do you do it? So what you do is this. We say negative 3b into negative 3bx. It goes how many times? Negative 3b into negative 3bx. So the best way you can do this one is to separate here, right? Negative 3bx is the one to be divided into, which is this one, by negative 3b. If you divide inside there, you say negative will cancel out the 3, cancel out the b, cancel out. We only have got the x. You put the x here. Let's move that way. Second, what we divide in negative 6b1 in divided by negative 3b. So you write negative 6b1 all over negative 3b. So that you see what remains. Negative into negative is positive. 3 into 6 is 2. B into B is 1, cancel out. We have got what? 1 here. At the end of the day, this into this one is actually positive 2, 1. Then that's what we need to write here, positive 2, widen your clause. Are you getting that right? First of all, check what is common, take it outside, put the brackets. What's supposed to be inside the bracket to be the quotient after dividing. The number you get after dividing that which is common into each. That's what will give you what's supposed to be inside the bracket. You never go wrong if you go by this. Once this is done, we move further. We also come to this one. Let's take out what is common. So from here now, we can, if you want, you can say, okay, let's also check what is common in between this one and this one so that we take it out. So then you see that what is common is 2a. So 2a, take it outside. Then for us, what's supposed to be here, we say 2a into 2ax. Yes, because the 2's and the a's will cancel out. So just have the x there. 2a into positive 4ay. It will be plus 2 into 4 is 2. A into A cancel out, right? We see the y there. We close. Are we seeing? Then just a matter of bringing this, which is already factorized here, so to be negative 3b open x plus 2 1 close. Lastly, we factorize further. Remember, it is complete. We've done the factorization, but this is not complete. So how do we factorize completely now? We once again still have two things. We have got two terms. This side, this part from here up to here, take note, and the part from here to this side. Between these two things or parts, we have got a minus here. So what is common between this part and this part? What is common? If you can check. What is common?
X plus 2y.
It is x plus 2y. It is this whole line. We have got x plus 2y this side and also this side. So we say x plus 2y, we put it in brackets, we take it out. You remember? Then we start now dividing this into each now. This into this will cancel out remaining the 2a. That's what we're going to put outside here, inside there. We come to this one. Again, this into this and this will cancel. So just have to put negative 3. Are we there? Then we do what? We close. And this becomes our answer. That's what we have. Remember, we are only simplifying. What is involved in simplifying? So what is involved in simplifying it is distributing. We're going to distribute. By distributing, I mean we're going to multiply this 3 times each inside. After which we group the like terms. So let's go. So say 3 by 4x is 12x. 3 times negative 5 is negative 15. Negative 15. Then we are done now here. We'll multiply the 3 times each inside. Then say plus and 2 there. Look at how nice this one is. So this is 12x negative 15 plus 2. It's negative 13. You check. Do we have anything in common here? Therefore, this is your answer. Okay, so this is the question that we have. So this is an equation. We are asked to solve the equation. So the moment we are solve the equation, it means that is actually an equation which they ask you to find the value or the variable. In this case, the variable that we have is y in this particular equation. This equation involves y, take note. So you must find the value of y. Now, if you look at the way the equation is, this equation is what we call a quadratic one. Why is it a quadratic? Because the highest power of y is 2. So if the highest power of the variable is 2, it means that we're going to find the 2 values of that variable or lambda. So if you see, the highest power of y in this whole lot of this particular equation is actually 2. This y is raised to the power 1. This other y is raised to the power 2. If you compare the powers, the highest power is 2. So this highest power 2 simply means this is a quadratic, which we are going to have 2 values of y. That's what it means always. Take note, always. So then how do you go about it? So we write the equation, that is 4y squared minus 8y, this gives us 0. So what you're doing here, first and foremost, people, I'll take you back to the quadratic equation in standard form. The quadratic equation standard form states that if you have got ax squared plus bx plus c is always equal to 0. This is the standard form you always follow. If and only if the highest power of x in this case is 2, this stands to become, the quadratic equation. Now, what's the point? The point is, we're going to find the two values of x because of the power 2 here. That's what it means. Now, we've got the expression and 0. From here up to here, we've got an expression. This expression has to always be equated to 0. Take note. The quadratic expression, it has to be equated to 0. Always. So if you have got a number, you need to remove that number to bring it on the side of the expression so that here we simply have got a 0. That's the order. In the case of this one, we have done things better for us. We see that on the other side we have got a 0 and on the other side we have got a quadratic expression. So we need to concentrate on the quadratic expression. Take note. So with this in mind, we are saying, I'll just try to bring you back to this one. So let's see how we now hammer this particular question. Take note. So what we'll do, we are going to say, we concentrate on the expression part from here up to here. So first of all, we can say, okay, let's try to factorize. Let's find what is common between 4y squared and negative 8y. What is common? What is common?
4.
For what? 4y. Here I've got a 4y. Also here 4y. We do have. Now let's see. So here I'm going to say 4y is common. You open the brackets. Remember what I said? 4y into this. 4y into this. Y. Just 1y. Very good. Then 4y into this. Remember this 4 is a positive. So positive into negative is negative. 4 into 8. So 4 into 8 is 2. Y, now y, they cancel. So we simply have got a 2 here, then we cross. Are we seeing people? Once we do this, you equate this to 0. When you reach at this point, you say either this 4y that you are seeing here is equal to 0, or this expression, which is y minus 2 equals to 0. Then we solve for y. Meaning, you need to remove the 4 by the verb, divide it. Cancel. You have y is equal to 4 into 0 is 0. One value of y is 0. The other one, we say, this we check the negative to the other side so that y here becomes a positive 2. Therefore, the values of y are 0 and 2. And that's the answer. That's how you do it. So if you write 1 and 1. Okay, let's look at the fifth question. The fifth question is on sets. And on sets, we are asked to shed A union B complement, A union B complement, in the brackets, intersection C on the diagram below. So what are you supposed to do? So the best thing that you can ever do is to look at what you are given. So we are given A, set B, and set C. That's what they're given. Now, how are they paired in the question? They are paired in such a way that we are told to say that the A goes hand in hand with the union B complement. A goes hand in hand with the union B. What we're supposed to do here is this. The way they are paired, we're going to go to our data. We say our data to do this. On your data, write A union B complement. Then we also write the set C. Take note. The question is about A union B complement intersection C. What does it mean? We are saying what is common. Take note. This symbol, it means intersection, meaning what is common between here and C. What is common in this set and in this set? What is common should be actually shared. Should be shared. So the best thing you can ever do is to write the numbers. We're going to write numbers. Check note as part and parcel of your working. So in each region, we'll put a number. You choose whichever number that you choose. So you can say, okay, the intersection part of both three sets you can put as 1. Here you can put a 2. You can put a 3. Here for just one number in each region, just one number. You can also put here as a 5, here as a 6, here as a 7, and lastly, the region outside the three sets, we can say that's number 8 there. This will help you. So that we try to see which region are we supposed to share? To share it. So then we go by pairs. We need to understand what is A union B complement. So first of all, we know to say A, it is the whole lot of this shape. Take note please. A, it is the numbers in A are 1, 2, 3, 6. Those are the numbers in A. We must also understand the numbers in the B complement. So we go by that order. So say, set A, observe. Set A has got numbers 1, 2, 3, and 6. Set B complement, on the other hand, it has got, remember, B complement, numbers that are not found in B. On the other, so where is B? Oh, B is this one. This will work and serve as a weapon for you people. B complement meaning the numbers that are not there in B. So meaning are 3, 6, 5, and 8. Yes, so we have 3, 5, 6, and of course 8. Are we there? This is a B complement. Now, we want to combine A and B by saying A union B complement. So say A in this way, A union B complement will equal to, when we say union, we are talking about the sum of these two. We combine them, but we don't repeat. If the number repeats, we just write it in once. So let's write them in order. So we have A1, comma, A2 in order, A3, A5, just use your eyes, 5, 6, and 8. This is the A union B complement. Are we there? This is it here, which is it? This part here. Now they say intersection C. You also do well to write your set C alone here. So your set C, you write it. Where set C is this one here. There are a lot of set C here. We have a 1, we have a 3, a 4, and of course a 5. That's what we have. At the end of the day, we compare what is found here and also what is found here. Are we there? This is A union B complement. This is it here. And this C is this one here. So let's compare what is here and what is there. So say, finally, we say A union B complement, intersection C is equal to let's compare. What do we have? 3. Then we have, okay, this one. Okay, let me just be cancelling. So I'll be marking this and this one. What else? 3. So let's write a 3 here, comma, a 5. Yes. What else? That's what. Okay. With this in mind, you go back there and say, oh, this is actually what is found in A union B complement and in set C. So then we are simply told to shade the region where we see 1, 3 and 5 only. So where is one region? Oh, it's this one. Shade it. Second, we go to 3. Where is 3? Oh, 3 is this one. Lastly, where is 5? Oh, 5 is this one. Shade it. And this becomes your answer. If you are to remove these guys, you see that we just have to put this region in the shade. That's the answer.